Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from IIT JAM MS 2021, problem number 60. The problem says that let phi mapping from -1 to 1 to the set of real numbers defined by phi of x is equals to integral x to the 7 from x to the 7 to x to the 4 of 1 by 1 plus t cube dt. If alpha is equals to limit x tending to 0, phi of x divided by e to the power 2 into x to the 4 minus 1, then 42 alpha is equals to, so basically we have to calculate alpha to find the value of 42 alpha, right? And phi of x is the function defined in the form of an integral, right? So we have to calculate the limit. See, this is the function, right? Phi of x. Now, obviously the function is hard to integrate. We don't know how to integrate this function. So we can't just integrate it and find this entire expression in a closed form in terms of x. We can't do that. At least it's going to be very difficult if even if it's possible. Even if it is possible, it's going to be very difficult. So, but see, phi of 0 is actually 0, right? Because if we put 0 in terms of x, if we put 0, x is equals to 0 in this function, then it is actually integral from 0 to 0, right? Because, and obviously this is going to be 0, so phi of 0 is actually 0, right? And this e to the power 2 into x to the 4 minus 1, this entire expression is also going to be 0 if we put x is equals to 0. So this entire thing, this limit is actually of the form 0 by 0, right? 0 by 0. So we can use L'Hospital's theorem, right? That means we can differentiate it, both the numerator and the denominator, and then we can proceed. So how do you find the derivative of the function phi? It's very easy. We use the Newton-Leibniz technique to differentiate it. So phi of x, phi prime of x, the derivative of phi is nothing but here. This integrand, this is the integrand here. So we are putting x to the 4 in place of t, and then multiplying it by the differential of x to the 4. That means the derivative of x to the 4. So here, first of all, replacing t by x to the 4 and then multiplying it with the derivative of x to the 4, which is 4x cube, minus again replacing this t by x to the 7 and again multiplying it by the derivative of x to the 7. So that is 7 into x to the 6, right? So this is 5 prime. You know that this is the Newton-Leibniz technique. Now this thing is nothing but, after bit of a simplification, this is 4x cube by 1 plus x to the 12 minus 7x to the 6 divided by 1 plus x to the 21. So this is 5 prime of x. This is the derivative of phi. Now alpha is this. So using the L'Hospital's theorem, 5 prime of x divided by e to the power 2 into x to the 4 times 8x cube, right? So 5 prime of x, we have already found out this thing. So taking x cube as common, this is 4 by 1 plus x to the 12 minus 7 into x cube by 1 plus x to the 21 divided by e to the 2x to the 4 times 8 into x cube. So just now it is very easy. We can easily calculate. This is nothing but half. So alpha is equals to half, and 42 alpha is nothing but 21. That's it. It was very easy. So all we needed to do was to know that we actually have to use the L'Hospital's theorem here, and obviously to differentiate this function we have to know the Newton-Leibniz technique, right? We have to know that, because obviously to find this integral in a closed form is impossible at this moment. So maybe not impossible, but it's going to be very difficult. We don't know how to do that. So anyway, it's this way is obviously very easy and fast to solve this problem. So yeah, there you have it. That's the solution to this problem. It's a very easy problem, a very basic application of Newton-Leibniz technique and the L'Hospital's rule. That's it. So do like, share, and subscribe to the channel for more exciting problems. See you till next time.